Hello everyone, in this video we will be seeing the notes, the presentation on data mining concepts and techniques. So stick to the video to get all the notes, to get all the presentation of data mining concepts and techniques. So we are starting the first chapter which contains introduction on data mining, what is data mining, multi-dimensional view of data mining, kind of data that can be mined, what kinds of patterns that can be mined, what technology are used, what kind of applications are targeted, and major issues in data mining, brief history of data mining and data mining society, and summary. So whatever the material, whatever the content which has been provided in this particular video are enough to write your exams or provide enough knowledge about the concepts that are there in the data mining. So why data mining? Why you require data mining? So there are many requirements where the data has to be mined, data acquisition, data collection, data pre-processing. So there is an enormous amount of data available and data is not available in the required format. So that's why data mining techniques become essential to extract the data, filter data, and keep the data ready for processing. So whatever the format we need, organization we need for processing, so data mining techniques provides the knowledge and tools and techniques about those to prepare the make the data readiness for processing. So data collection and availability, automated data collection tools are there, database systems are there, web computerized society are there. So these are the huge collection of data sources. So major sources of abundant data are from business web sites, e-commerce websites, transactions online, stocks, etc. And from the science domain, it is like remote sensing, biometrics, geospatial data, scientific simulation like NASA used to do. And then from society and everyone, like social media, news, digital cameras, YouTube. So abundant of data is available. So we are downing in data but starving for knowledge. We have enormous amount of data but not as required as we want. Yes, so that's where the data mining is required, and that's where the data mining plays an important role to prepare us the data for processing. Data required in required format is a necessity, and necessity is the mother of invention. So let us explore data mining. So how exactly it extracts and prepares the data for processing. So evolution of this it came, where exactly it came from. So this you have to study by your own. Not exactly the important answer or equation that can be asked in example, but for the knowledge sake, you have to see the evolution with respect to data, and where exactly the data mining concept came from. So who coined the keyword data mining, and what exactly it is. So all the details are provided here. Evolution of database technology. Yes, in 1960s, during the invention of the computer related device, data storage devices, the concept of data collection came, data creation and IMS and network DBMS started. In 1970s, the researchers who are dealing with storing data has also thought of having a relational data model and relational DBMS implementation. In the 1980s, RDBMS and advanced data models, extended relations, object-oriented and detective-based. So all those concepts started. Application-oriented DBMS started based on spatial, scientific and engineering models. So next, in the 1990s, where you had the computers, sophisticated computers for storing and processing data, there exactly the requirement arose related to data mining, data warehousing, multimedia databases and web databases. So in 2000, where we had the internet, the connectivity, where enormous amount of data is being generated, there exactly the major requirement for data mining techniques arise. So we are getting data from streams, those need to be managed and mined, important details to be mined from there. Data mining and its applications started there, and web technology, XML data integration and global information systems started, where the generation of data started, where huge amount of data has to be managed and important patterns from those huge amount of data has to be extracted. The question is, if there is a huge amount of data, how to manage it? To manage it, how to organize it, and to organize it, how to view it. Physical data cannot be accessed like faster, and cannot be used for processing. So you need to have a logical models using which you can perform a lot of operations on data. So for that you need a multidimensional view of a huge amount of data. So this is a major challenge. Let us learn about what is data mining. Data mining is nothing but knowledge discovery from data, extraction of interesting, like non trivial, implicit, previously unknown, and potentially useful patterns or knowledge from huge amount of data. So it's exactly extracting important business oriented knowledge from huge amount of data. So the alternative names of data mining is the knowledge discovery in databases, knowledge extraction, data or pattern analysis, data archaeology, data dredging, information harvesting, business intelligence, etc. So this diagram is really important. In exam you may come across this question like what is exactly a knowledge discovery process, or what is KDD, what is data mining. So for all those questions you have to answer this diagram. So this is a view from a typical database system and data warehousing communities. The data mining plays an essential role in knowledge discovery. So let us start with the first step, which is data integration. After that you will come across the data cleaning process. Data warehousing will happen. After that task relevant data will be taken, and next data mining will happen. After that you will extract important patterns from data, and the pattern evaluation will be done. So this is exactly a very important diagram where you move from data to towards knowledge, like you are in a process of extracting knowledge from data. So example of a web mining framework here they have given, like from internet you have lot of data, huge amount of data. So what exactly you how exactly you treat, or how exactly important patterns can be extracted from web data. So data cleaning will be done, like you have so much of data, so whatever the required data is there, whatever important data is there, that should be taken and should be cleaned out. Cleaning involves like removing the unwanted data, or including the relevant data, or taking the relevant data from huge amount of data. So after that you need to perform data integration from multiple sources. Like you have multiple sources from where the data is being generated, so you need to integrate that multiple sources data into one source. So warehousing the data, organizing the data so that it can be taken into consideration, it can be taken into transformation. Later that you have to construct the data cube construction. Data cube is a logical model for data representation. Data selection for data mining will happen, and data mining will exactly happen the presentation of the mining results in terms of patterns, and knowledge to be used or stored into knowledge base. So this exactly what the diagram explains, whatever we have seen till now. So it's all starts from data sources, example papers, files, web documents, scientific experiment data, or database systems. So data pre-processing will happen where the important data will be extracted. Data from multiple sources are integrated, and it has to be stored. So after storing the data exploration happens, like statistical summary, querying, and reporting of those stored data will happen. And then is what exactly the data mining, information discovery from this collected data. So information discovery means analysis of data. Important patterns will be extracted after analyzing the data. So after extracting the pattern, it has to be presented, or visualization technique, the presentation of this will happen, and the decision making will happen based on those extracted patterns. So exactly data mining increases the potential to support business decisions. So whatever the automation is happening in AI is because of the decision making capability of machines. And how does machines get capable to make decisions? So it's because of data mining. So mining versus data exploration, like business intelligence view, warehouse, data cube, reporting but not much mining, business objects versus data mining tools, supply chain examples, data presentation and exploration. So KDD process can be represented in a typical view like data pre-processing, data mining and post-processing. So let us move on to the multidimensional view of data mining. Multidimensional view of data mining is exactly in this multidimensional view of data mining. You have to like view the data in a different way, like what data to be mined, what knowledge to be mined, what techniques to be utilized, and for what application the data will be used. So data to be mined is from the database data, data warehouses, or transactional data streams, spatiotemporal time series, sequence, text and web, multimedia, graphs and social and information networks. So knowledge to be mined, like data mining functions, whatever you have to use to relate data, perform aggregation functions. So these functions can be characterization, discrimination, association. Association is logically linking data. Classification means depending on the classes of data, data is classified, clustering, segmentation of data, trend, deviation, outlier analysis. So these are the important like data mining functions you will perform. So descriptive versus predictive data mining is there, and multiple integrated functions and mining at multiple levels is there. So what techniques you use, like you use data intensive techniques, use OLAP, machine learning, statistics, pattern recognition, visualization, and high performance. And lastly, where you will utilize the mine data. So you can utilize it in retail segment, telecommunication industries, banking industries, fraud analysis, biodata mining, stock market analysis, text mining, web mining, etc. Applications are plenty for this. So on what kinds of data that you perform data mining? So database oriented data sets and application, like see the major question is whether the data mining can be performed on a unstructured data. No, it has to be structured. It has to be in a format or in a structured format, so that the important patterns can be extracted. You cannot perform data mining functions or data mining techniques on unstructured data. So you need data into some structured format. So data can be like organized data or structured data is available in relational database format, data warehouses, and transactional database. So you have other advanced data sets and advanced applications like data streams and sensor data, time series data, temporal data, sequence data, structured data, graphs, social networks, and multi-linked data, object relational databases, heterogeneous databases, and legacy databases, spatial data and spatiotemporal data, multimedia database, text database, and World Wide Web. So the first data mining function is generalization. So how do you generalize data? So what technique you use, what data representation you use. So here we need to perform information integration and data warehouse construction. Like we need to perform for data warehouse construction, we require some pre-processing where the data will go across. Has to go some process that begins with the data cleaning, transformation, integration, and multi-dimensional data model. So these tips we will study in detail in the coming chapters. So data cube technology is a representation of data if the data is scalable methods for computing and multi-dimensional aggregates. OLAP is an online analytical processing tool which uses this data cube for organization and computation of data. So you also require multidimensional concept description where characterize and discrimination is done. So where you generalize data means summarize the data and contrast data characteristics. So this is the first method function. The next function is association and correlation. Association means logically relating things. So where is association like required, where you have frequent patterns, frequent item sets, like what items are frequently purchased together in your Walmart. So this is very important. Association in real world, we can tell you, like if you go to a Walmart or some shopping mart, so where frequently bought items are placed close to each other. So how they have come to know, so how they have extracted this pattern from the purchase history. So they analyze the purchase history and see which are the frequently bought items. Like if a person purchases milk, definitely he'll purchase some bread. Okay, so bread and milk are kept side by side so that the large number of sales can happen. So this is a kind of association. Like association means relating the things logically. So association, correlation, and things, these are the concepts that you will learn, and these are the important functions of data mining. So how to mine such patterns and rules efficiently in large data set is a question, and how to use such patterns for classification, clustering, and other applications. So definitely these association helps in classification and clustering. Next, you have classification, like classifying data based on its class, like label prediction is it. Construct models based on some training examples. So you train the data based on training you to classification. Describe and distinguish classes or concepts for future prediction. So example, classify countries based on climate, or based on currency, based on class, or classify cars based on its gas or petrol or diesel. And after classification, you use this classification to predict some unknown class labels. So typical methods used in the classification are descent trees, neo-Bayesian classification, support. Typical application is credit card for fraud detection, direct marketing, classifying stars, TCs, weapons. There are numerous applications for this. Cluster analysis, if you have unstructured data, then only you can go for clustering, because classification requires the data to be labeled or structured. So unsupervised learning, where you don't have any training kind of thing, because you deal with the unstructured data where the class label is unknown. So group data to form new categories, example cluster houses to find distribution patterns. So principle here is maximizing intra-class similarity and minimizing inter-class similarity. So many methods and applications are there for cluster analysis. So lastly, we have outlier analysis. Outlier is a data object that does not comply with the general behavior of data. So for example, noise or exception, or one person's garbage could be another person's treasure. So methods here is the byproduct of clustering or regression analysis can be done to identify this outlier analysis. So useful in fraud detection and rare event analysis. So these are some of the data mining functions, and it's an important important concept, important question that can come into the exams. So this is what we have covered till now. You can see the next in the next video the remaining concepts. Thanks for watching. Take care. Bye bye.